Hello everyone. In this video I am going to show some of the important probability distribution that you need for a better statistical inference analysis when you will be making a lot of data analysis and a lot of statistical inferences, model fitting and model prediction. So this video will help you in that. Let me start with discrete random variable. So in discrete random variable, you know that probability distribution function is probability mass functions because it is discrete. Let's start with uniform distribution. Uniform distribution from A to B, we are assuming that it is discrete, like it is an integer a plus 1, a plus 2, so on to b. Okay, and this is the PMF. So it is written as p of x is equals to 1 by b minus a plus 1, where x belongs to a plus 1 dot b. So the probability of each outcomes of a random variable x is same and which is equal to 1 by b minus a plus 1. Second is binomial distribution. In binomial distribution, it is how binomial distribution says, let's say x is a random variable representing number of success in an event. So PMF of x is equals to ncx p raised to x 1 minus p raised to n minus x, where x belongs to any non-negative integer like 0, 1, 2, 3 to n. Now come to third is negative binomial. Negative binomial representing a random variable where number of success in an event but last trial should yield success. What is the difference between binomial and negative binomial? Binomial says that, let's say that you toss a coin n number of time, okay, and you get like might be head, tail, head, or anything. Okay, so let's say you toss till n times, you get x head and n minus x tail, right? So the probability of success is ncx p raised to x 1 minus p raised to n minus x, right? But in negative binomial, it says that last trial should yield success. Means in the first trial, maybe head, tail, whatever it is, in the nth trial, this has to be the success. Let's suppose our success says head. So it will be head. So whenever the head will happens in the last trial, the events stop, right? It is similar of saying that we are getting n minus 1 success in x minus 1 success in first n minus 1 event and nth will be success, right? So it is similar to, like, if you go the derivation of this PMF, then you will say that, okay, what is the probability that I will get x minus 1 success in n minus 1 trial? It is n minus 1 c x minus 1 p raised to x minus 1 1 minus p raised to n minus 1 minus x minus 1, right? It will be 1 minus p times n minus x. And since we are having n trial, so we are multiplying by p. Why? Because it is for sure that the last trial has to be success. And what is the probability of success in the nth trial? It is p. That's why we are multiplying by p. When you do this calculation, you will get n minus 1 c x minus 1 p raised to x 1 minus p raised to n minus x. Now come to Poisson process. Poisson process, let's consider x a random variable representing occurrence of k event in x trial. You can say that, let's say, at every minute on a road, there is a probability of having an accident. So let's say this is the first minute, second minute, third minute, fourth minute, and so on. Let's say an event. What is the probability that there is a k accident in these n time? It is written as probability of k event k accident in x time is equals to gamma x raised to k e raised to minus gamma x divided by k factorial, where gamma is the parameter of the parameter of the Poisson process. Now come to the geometric distribution. Geometric distribution, we say that there is a first success in the nth trial. Okay, so let's say that I let's say that the event occurred x number of time. So what is the probability that first success of the event occurred in the xth event? It is equals to, like, there is a failure till x minus 1, so 1 minus q raised to x minus 1, and there is a success in the xth event, right? Now let's start with continuous distribution. First is uniform, as similar to discrete. We have also a uniform in continuous distribution. Let's say that x is taking a value between a to b, then f of x is written as 1 by b minus a. Second is normal distribution, which have a two parameter, mu and sigma square. Mu is mean and sigma square is variance of a distribution. It is written as f of x equals to 1 by under root 2 pi sigma times e raised to minus half x minus mu by sigma ka whole square, and x belongs to whole real number from minus infinity to infinity. I am sure that you must be knowing about this distribution. This has a bell-shaped distribution with mean mu and standard deviation sigma, right? Now let's come to log normal distribution. If x is log normal distribution, then PDF of x is 1 by under root 2 pi sigma x e raised to minus 1 by 2 log x minus mu by sigma ka whole square. One important properties of log normal distribution is that, let's say that x is log normal, okay, then y equals to log x. If x is log normal, then log x will be normal distribution. That's why I am using the similar parameters mu and sigma square for this. But don't confuse that mu and sigma square is the mean of this distribution. You have to calculate the expectation value of x here in order to calculate the mean and variance of the log normal distribution function. Fourth is exponential distribution. It is written as f of x equals to lambda times e raised to minus lambda x, where lambda is greater than 0 and x belongs to close open interval 0 infinity. Graphically, you can see how it is being drawn. I hope you get sense of the important distribution in statistics. Let's see you in the next video. Thank you.